All right, guys, we're looking at another set of 6 free response questions. I've tweaked the first couple that were calculator questions because they were good questions and made them non-calculator. And so you shouldn't notice a thing when you look at them, except perhaps at times some of the integration might be a little weird, cause you to really know your U substitution, that kind of stuff, which you can probably expect this year. It being an open notes test and all. So anyway, 6 pretty good problems. We're going to take them 2 at a time, 2 each day, and we'll be looking at number 1 and number 2 today. So good luck. And if you're just getting back with us, welcome back. If you've been taking a long sabbatical, again, focus on the process. Listen to the things that I'm saying. If you need to increase the playback speed, that's fine. But make sure that you're processing through these things. And again, if you don't know how to do something, make sure you're making a list of those things, or at the very minimum, making little sheets or note cards that you can have around your computer when you take this test, so you don't have to go digging for that stuff. All right, good luck, guys. All right, so here is number 1. I know that I have said in the past that AP was omitting volume from their test, but that's technically not true. They're omitting rotational volume and cross-sectional volume questions from the test. So that doesn't mean they couldn't ask you about something to do with volume like they do here. The thing that you need to know as you're reading through this, they're going to be mentioning volume in a second on part A, and you know that if you're dealing with anything that has a uniform cross-section like a cube, or a a circular cylinder, anything like that, if you know the area of the base, you can multiply it by the height. And basically that's what they're kind of giving you in this first question. So evidently there's this tank, it's 10 feet high, and you can see that this table is giving you certain measurements of the height, of the area of this tank at certain heights, at 0, 2, 5, and 10. And it has a height of 10 feet. The area of that cross-section of that height is given by this function. So this is not a cross-sectional volume problem that I'm going to be asking you about, but you do have to understand a little bit about volume. It says where the area is measured in square feet. It says the function A is continuous. So whatever that area function is, I can assume it's continuous, and it is decreasing. So as h increases. So as the height gets higher, the area gets smaller. So maybe it looks like who knows? Maybe it looks like a pyramid. Maybe it looks like a upside down cone. Who knows? But right here it says use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume. Well, it kind of makes sense that area in h squared times height h is going to give you feet cubed, and that's volume. So if I'm doing a left Riemann sum, I always want to, I'm definitely going to want to say volume. And if I want, I could say I'm going to integrate the area function from 0 to 10, and then that dh, dh, not ht, sorry. That dh is like the dx. Okay, so the dh right there is like change in height times the actual area, and that gives us our volume. So it's a little bit like a cross-sectional area, a cross-sectional volume problem, but I wanted to do this because it was a Riemann sum. It's pretty simple to do. My bases are 2, 3, and 5, and because it's a left Riemann, I'm going to take that base with the left height, left height, left height. So I end up getting 2 times the 50.3 plus 3 times the 14.4 plus 5 times the 6.5. And you don't have a scientific, you can use a scientific or any calculator on this test. So 100.6 plus, that's a 43.2 plus a 32.5. And all of that adds together to give me 176.3, and you can write cubic feet or feet cubed either way. Okay, and the way they gave you points on this was you got 1 point for actually doing the setup right here. So you got 1 point for that, and then you got 1 point for your answer. So, and then it didn't say, it did say indicate units of measure. So you got 1 point for getting the units in A and D. So by getting those units correct right there, feet cubed, which is volume, you got an extra 0.1. And if you left them off here, but you did it right in part D, then you also got credit as well. Okay? But they needed to see that you knew that what volume was. Okay, so that's number 1, up to 3 points there. And then number 2 says, does this approximation in A overestimate or underestimate the volume? Well, again, if you have left Riemann sums and this function is decreasing, I'm going to draw you a little picture of that. But if you have a decreasing function and on a Riemann sum, right, you're bringing it up until the left side hits. Well, if the left side of that rectangle hits, left side, left side, left side, you can clearly see that this is an overestimate. But I got to put my answer in the box, so I'm going to say this is an overestimate of volume, but you got to say, explain your reasoning. So how do you explain it? You're going to say left Riemann sums overestimate decreasing with overestimate, you could just say decreasing functions. But they're going to look for 2 things. They're going to look for you to state that it overestimates, but also decreasing functions. And on this particular value, you only got 1 point if you said that correctly. If you just say overestimate, nothing. Okay? Part C was asking you actually what the volume was, but we're skipping that part C because this year's coronavirus test will not include that. So I'm going to jump to part D. It said water is pumped into the tank. All right. So I've got water pumped into the tank now. All right. So imagine this big tank, water's getting pumped in. It says when the height of the water is 5 feet, the height is decreased. So when H is 5, I'm going to write down what they give me. Okay. When H is 5, it says the height is increasing at a rate of this. So how do you write height is increasing at a rate? dH dt is, and it says increasing, so positive, 0.26 foot per minute. I know what you want to say 0.26 feet per minute, but that's like a quarter of a foot per minute. All right. Then it says if the volume is modeled by this expression, find the rate at which the volume of water is changing. So what is the rate at which volume changes? That is dV dt. Well, if this is V and I want dV dt, I'm going to have to take the derivative of both sides to get dV dt. So let's see if we can do that. So to do that, you got to be careful with this. So dV dt would be me taking the derivative of the left side. And then for me to take the derivative of the right side, I'm going to have to d dt the integral. 0.2x plus x. And this is where a lot of people went wrong on this problem right here. A lot of people did that. And then a lot of people said, oh, wait, I know that this is the second fundamental theorem. And the second fundamental theorem of calculus says that the derivative and the integral cancel each other. And then you take the h and you plug it in wherever there's an x, which would be there and there. So the first step I would have for dV dt would be to plug the h in. So 50.3 over e to the 0.2 times h, right? And then plus h. So you're plugging the h in for x, and then you take the derivative of the h, and here's where people went wrong. People go times the derivative of h is just times 1. Well, you're used to having an x there, and the derivative of x is 1, because really, if there's an x there, you're going 1 dx, dx. And the dx is always canceled, so you're left with 1, and you don't bother. But in this case, you're taking the derivative with respect to t. So the derivative of h is not 1 period, it's dh dt, because you're taking the derivative with respect to time. So you have to go dh dt. And if you don't do that, then when you get down to simplifying this problem, you end up not being able to insert this 0.6, this 0.26. So that's the derivative. And the question was, find the rate at which the volume of water is changing, right? At the time, with respect to time, when the height is 5. So what I'm going to do now is go, all right, the rate at which volume changes, dv dt, when h is 5 is, and notice how I labeled it, right? 50.3 e to the 0.2 times 5 plus 5 times dh dt, so times 0.26. And right there, guys, I'm done. I mean, if you want to go a little further, you can. If you want to take all this and multiply it together, but this test said you don't need to be able to have a calculator. So if this is a problem, you can leave it. Now, if you don't leave it, and you were to come in here and say, well, that gives me e to the 1 plus 5 times 0.26, I suppose you could. I'm not going to do that on this test. This was not a calculator portion. You don't need to know how to do this. But if you did, you could come out here if you're just wanting some clarity. That 50.3, I could divide. Sorry, let me just make a fraction. So 50.3, you can take that and divide it by, and heck, even if you didn't want to do the multiplication, you could do e to the 0.2 times 5, come down, add a 5 to it, and then multiply by a 0.26, and you're going to get 1.694. And this is change in volume, sorry. Okay, so even if I did plug the value in there, you can see that in my work. Okay, I get 1.694, and change in volume is feet cubed. Time, it said the time is measured in minutes. Okay, and if I know that because I went back and read D and it said 0.26 foot per minute. So I'm going to put minutes there. Okay. All right, so if you got those units right, or if you got the units on the other one right, you got a +1. This particular one, you got 2 points. You got a point for actually showing you that you needed to take the derivative of v with respect to t, which I believe is just this setup. You got a point for doing that, and then you got a point for getting this right, this part right, and then you got a point for your answer, whether you wrote it like this or like this. And I can't emphasize enough on this test, you do not need to do massive simplifications like this. It's okay to leave it if it's a non-calculator problem, which this will be on this test. Okay, so those are 3 more points. And again, 2 of the points were left out because you could only have gotten 6 for this because we left off part C. All right, so let's take a look at number 2. Okay, number 2 is talking about, again, this is modified for no calculator. The original problem, you were unable to actually take the integral of it. And this was quite a bit uglier as well, but I made it a no calculator problem because the concepts involved in it are pretty good. Okay, so you're going to be staring at the same sheet I am, so you won't even have known it was modified. Anyway, so it says when a certain grocery store opens, there are 50 pounds of bananas on a display table. So you got a table, there's 50 pounds of bananas on it at when it opens, so at time 0. And then it says, customers are removing bananas from the table at a rate modeled by this function. So for the next 12, whatever, and then it says F is measured in pounds per hour. So for the next 12 hours, this function models how the bananas were leaving the table. All right. And then T is the number of hours after the store opened. It said once the store has been open for an hour, so after an hour of having bananas removed, store employees begin adding bananas back. Now what you need to focus here is that this is a rate at which bananas are what? Removed. And then this next function is also a rate, okay, at which bananas were added. So, and then you also have an initial amount of 50 pounds. These are the things that you have to see about this really quickly. So I'm given 2 rates and an initial amount. Now the first question is, how many pounds of bananas are removed? So it only is asking about removed. It didn't say how much have anything to do with what was, it didn't say how many bananas are left. It said how many were removed. So I'm going to use this removed rate function. And how do you get an amount out of a rate? Yes, you integrate the rate, which is 10 plus pi t sine of pi t squared over 4 dt. And then I want to know, it says the first 2 hours the store was open. So from time 0 to time 2. So I'm not going to take this and add it back to the 50 or subtract it from 50. I'm not going to do that. That would tell me how many bananas are left on the table. And actually that wouldn't even be true because at time 1, they started adding more on there. So that's a totally different question. This alone will give me the amount removed. All right, so it says how do I actually evaluate this integral? Okay, so to do this integral, I see a plus sign there, so I can take the integral of the 10 and then plus the integral of this part. So I think I'll do that. I'm going to take the integral of that, and then I'm also going to just help me visualize this by taking the integral of that too, and I can even put a little dt in there if I want to separate that. So the integral of 10 is 10t from 0 to 2. So I'm finished with that part. You can go ahead and evaluate that all the way. You get 20 minus a 0 right there, so you get 20. So we're done with that part of the integral, and then I'm going to come back and now deal with this part. Now this part's a little trickier, okay? Because this is definitely not a rule from my sheet, which you probably need to have right there with you if you happen to see some weird integrals. But I do recognize sine, and the only formula on my sheet that has a sine is sine of u du. So I'm going to try to make that my u and just hope it works out. So if u is pi t squared over 4, then du is 2 pi over 4 t to the first dt. So I'm going to go 2 pi over 4, which is really just pi over 2, right? When I multiply the 2, t dt. So again, 2 times the coefficient, which gives me pi over 2, and then t to the first, and then derivative of time. Now that right there, I can see there, there's a t, right? So there's my dt, and there's the t, but I also need a pi over 2. So I'm going to need to have a 2 under that pi to give me the pi over 2 that I need. And can I randomly just walk and put a 2 under without putting a 2 on the outside? And the short answer is no. So that I'm going to drop the 2 down, and then I'm going to rewrite this as sine of u du. And then I'm going to bring the 0 and the 2 up. Okay? So at this point, it shouldn't be a big deal. I'm going to go plus 2, and the integral of sine is what? Negative cosine of u. So I'm going to plug my u back in there. Some of you are like, man, that's a terrible looking u substitution. We're not worried about that, right? And then that's what I get for that. And I need to mark it from 0 to 2 to let the reader or whatever I know who's reading this be in good shape. So I'm going to plug a 2 in. I'm going to plug a 0 in. And then I'm going to subtract them. So let's be careful about that. When I plug a 2 in, I get 4. 4 over 4 cancels, and I get cosine of pi. Cosine at pi, which is to the left, is a -1. A -1 times another negative is a +1, and a +1 times a 2 is a 2. Then I'm going to plug a 0 in there. 0 times everything is 0. Cosine of 0 is +1. +1 negated is a -1 times 2 is a -2. But because I'm subtracting that, I end up adding, and I get 20 plus 2 plus 2 is 24. And this is pounds of bananas. Okay? So the first problem I thought was pretty great. You got 1 point for just setting up the integral even if you did nothing. Okay? You got another point for evaluating this integral right here. For evaluating that integral right there. And then you also got a point for your answer. I believe that is how, actually, no, they didn't. They gave you 1 for the integral and 1 for the answer. So they didn't even, oh, but this was a calculator portion. Yeah, so because we're not using a calculator, they would have given you an integral for actually evaluating this correctly. They might have given you a point for doing the whole integral correctly. So for getting this part right here done, either that or that, you got a +1. So we're going to say that this is worth +3, which will probably mean this problem will be worth a +10 somehow. But anyway, I'll show you all that in the grading. If you look back at Schoology, I'll show you kind of, if you want to figure out maybe what you got, I'll give you all the points for number 1 and 2. I'll give you a scale based on that. Okay, part B, it says find the derivative of the function f at 2. All right, so that should be right in our wheelhouse. The derivative of f, if f of t is 10 plus pi t sine of pi t squared over 4, if that's my function, I'm going to want to take the derivative of that function, and this is with respect to time. Okay, so anytime I take a derivative of t with respect to t, I don't have to write dt dt. Okay, so right here, I'm going to take the derivative of 10, which gives me 10. Oh, wait a minute. So I'm taking the integral. The derivative of 10 gives me what? 0. Okay, so that gives me a 0. And then I get to this part and I go, wait a minute, what do I got here? It looks like I have a product rule. I have pi t times sine of something t. So I'm going to have to go plus first, right? First d second plus second d first to get this entire derivative done. All right, so here we go. First would be the pi times the t, and then the derivative of sine of blah is cosine of blah times the derivative of that. And we've already actually taken the derivative of that when we did our u substitution, but if I want to do it again, I get pi over 2t. All right, so pi or pi t over 2. It doesn't really matter how you want to think about it. So all of that part is my d second, okay? And you don't have to have the dt part in there because the derivative of t is 1 with respect to time. Plus second, so I'm going to copy the second part down right here, d first, and the derivative of pi t is just pi. So that's my derivative, but I want the derivative at 2. So 0 is irrelevant here. When I plug this in there, I get 2 pi. Okay, now I'm going to do the second part here. If I plug a 2 in there, I get 4 over 4, which is 1. So I'm taking the cosine of pi, and the cosine of pi is -1. If you don't know that, you ought to have a copy of your unit circle, and you should be looking at pi radians straight to the left in the unit circle and grabbing the x value. All right, and when I plug a 2 in there, the 2's cancel, and I get another pi. And then when I come over here, if I plug a 2 in there, I get 4 over 4, which is 1. So sine of pi, that's a 0. And of course, 0 times everything goes away. And I'm left with -2 pi squared. And what would this mean? If f is the rate at which bananas are removed, then the derivative of f, this is what I have to say next, using correct Unix, explain the meaning of that. Okay? So to explain the meaning of the derivative of f, okay, I need to first understand what's going on here. Well, if F is defined in pounds of bananas removed per hour, then the rate of that would be pounds of banana removed per hour, or per hour squared. And the way you might remember that starting out is, you know how velocity is like meters per second, but if you took the derivative velocity and got acceleration, it would be meters per second or per second squared. So just square whatever the denominator unit is. So how do I describe this in the meaning of this, the context of this problem? Well, a lot of people make the mistake of saying, oh, this means the derivative of the function at 2 hours. Guys, that is not in the context of this problem. That's in the context of calculus. I want to know about in the context of the problem we're dealing with right here. Okay, so if f is the rate at which bananas are removed, then this is the rate at which the rate is changing. Okay, so you could say one of two things. You could say, and the second way is going to be better, but you could say that f prime of 2 is the rate at which the rate that bananas are removed from the table is changing in pounds per hours squared. So that's one way to say it, but I think another way to say it that was pretty great is to say that you maybe could say something like this: bananas are removed. Let me see, how about this? How about this? How about this? This would be a better way. How about, I know I'm stalling right here. How about this? The rate at which bananas are removed is decreasing. You could say that. So the rate is changing. I'm saying the first one said the rate at which the rate is changing. I'm saying the rate at which bananas are removed is decreasing. And the reason I said decreasing is it was negative. I could have said it's changing at -2. I'm just going to say it's at -2 pi squared. I'm going to say it's decreasing at 2 pi squared pounds per hour squared. And I know you're not supposed to put anything outside the box, so make sure you don't do that. All right? You're not allowed to extend the box like I just did. But again, I don't even know if they're going to have boxes on this test because of the whole nature of this, of the way they're grading it. So the way they're going to give you credit on this thing is you're going to get credit for the derivative being correct. So +1 for that. You're going to get a point for the answer and a point for one of these kind of explanations. But guys, when they say in the context of the problem, make sure you don't talk about, what f prime means, like it's the derivative of the f function. Don't say that. At time 2 hours. Don't say that. You're not going to get credit for that. They're talking about this particular word problem, all right? Not the inherent idea of calculus illustrated by f prime. Okay, so far we're looking at 6 points here. If we look I adjust and give you extra points for actually calculating the derivative and calculating the integral, which AP would not have done on this particular problem because it was a calculator problem, but we're doing, so this problem is going to probably end up being worth 11 and the other one 7. But it's great calculus to be looking at. Okay, all right, so that's part A and B. Let's look at C. Okay, so C says, is the number of pounds on the display table increasing or decreasing at time 2? Okay, so how would you determine if the number of pounds is increasing or decreasing? Well, if you ask me, if the number of pounds is increasing, that means the rate at which the store employees are adding them is greater than the rate at which they're being removed by customers. Okay, so I really am looking at F and G. So if F, and really you're going to get credit right here for considering the rate at, you're going to have to know what F of 5 is. You're going to have to figure out that, and you're going to have to know what G of 5 is. So you have to be able to look at F of 5 and G of 5, and if the removing is greater, then that means that the number of pounds is decreasing. So really you're getting a point for each of these, and then you're going to get a point for the actual value. So really not a whole lot of calculus in this. It's just making sure that you understand that I'm looking at rates right here. So F of 5, and this may be a little bit hard to deal with, but let's just take a look. Gives you 10 plus, and you do have a calculator, although they're telling you that the calculator is not going to be necessary. But I'm plugging a 5 in here, and I get pi 5 squared, which is 25 over 4. Okay, and then on G of 5, I have 7 minus 0.5, and then I have 5 plus 2. So the G of 5 is a little bit easier to figure out. This is 7 minus a half of 7, and a half of 7 is 3.5. So this G of 5 is about 3.5. Now, you do have a scientific calculator, so you could type this in, but I just want to show you how you could have done this without it. Okay, so right here, and you might already be getting a clue about this, but this is what I have so far, 10 plus 5 pi, and I've got to figure out what sine of 25 pi over 4 is. So let's think about 25 pi over 4. Now 25 pi over 4 is way beyond the unit circle's max of 2 pi, right? Because 8 pi over 4 would be 2 pi. So I'm going to look at this and I'm going to start subtracting off 2 pi's. So 2 pi's would be like 8 pi over 4, 8 pi over 4. And I'm going to keep subtracting off 8 pi over 4's. And when I do that, I get down to sine of pi over 4. And we know that that is root 2 over 2. Okay, so whenever you have too many radians, if it's a manual problem, subtract off 2 pi's until you recognize it on your unit circle. All right, so I'm going to insert square root of 2 over 2 right here. Well, I don't have to do all this math. What do you clearly see right here? You clearly see that this amount right here, right, I've got 10 times 5 times 3.14 times, this is roughly about 0.7 or, you know, whatever it is, it's definitely bigger than 3.5, right? And F is the removing. So if I'm removing them faster than I'm replacing them, right? If I'm removing them faster than I'm replacing them, then what should that mean? Well, that should mean that the number of pounds is decreasing. Okay, so I will say it's decreasing, right? And give a reason. Well, I could say F of 5 minus G of 5 is a greater than 0, is a positive number. So that means it's decreasing because that. Is that making sense? And you could also say G of 5 minus F of 5 is less than 0. All right, so you could say the number of pounds of bananas is decreasing because that. Right? Because if that's positive, then the rate at which they're removed is positive. It's a bigger number. All right, so part D. Part D right here, we're going to set up what I would do to find how many pounds of bananas are on the display table at time equal 3. So part D asks how many pounds of bananas are on the display table at time t. Okay, now everything's getting brought together on this. So how many pounds are on the table? So the number of pounds on the number of pounds of bananas on the table. Okay, so think about what that is. That's going to be basically your fundamental theorem. Now remember, your fundamental theorem says if you integrate a rate, I'm just going to write it like this. If you integrate a rate from A to B, right, you get a new function, an amount function from A to B, which is really the amount of B minus the amount of A. And if A is times 0, which it is in our case, then the 0 would go over here, right? So if you think about that, if I take this integral, and remember, when you integrate a rate, you get a change in the amount. So that's the change in the amount. If I add the initial amount back to it, to the change in the amount, that gives me the final amount, the amount at the end. So that's my thinking right here that I'm going to go by. So what I'm going to do is I'm going to start with my amount 0, and it told me that I had 50 pounds on the table before I began, or right there at the beginning of the day, right when the store opened. So I'm starting with a 50. But here's the difference. Now, my change in my amount not only is changing on what's being removed, but it's also changing on what's coming in. Okay? So I'm going to do an integral right here of my f function, which is 10. Actually, this is being what's removed right here. So I'm going to go minus that. So 10 plus pi t sine of pi t squared over 4. And I've actually already done this integral. I was doing it, I believe, from 0 to 2 maybe. We're going to be doing it from 0 to 3, but I can still use the actual integration that I've already used. And then I'm going to replace or add more bananas back with the g function. So I'm going to add back how many were added. Now, you got to be careful on the amount added back, because the amount added back, here is my function, right? But this function is good for time what? for time t from 1 to 12. Okay, so this one, I'm not going to go from 0 to 3 because nothing was added back from 0 to 1. I'm going to go from 1 to 3. Okay, so a lot going on this one. Initial amount, this is the number that's removed, so I'm going to subtract those. This is the number that's added back. And that's it. So on the real test, they had you actually typing all that junk in your calculator and giving you a point for the answer, but they didn't give you a point here. We're going to give you a point for that setup, and a point for that setup. And the algebra on this, or the calculus on this, is doable, but it's really gross. So we're just, well, it's not so bad here, but it's really gross here. You've already done it once. You'd have to do it again. It's just a big mess. So we're going to just stop right there and call that 3 points. And by the way, back here up on part C, I didn't give you your points here. But on part C, let's see how they had that scored. You got 1 point for considering each of those, and then 1 point for making a statement like this. Now, you could have also said something like, oh, f of 5 is greater than g of 5. You could have said that, and therefore number of pounds is decreasing, you know, something like that. But you basically had to evaluate the f of 5 and the g of 5 to get that last point. All right, good luck, guys. I'll see you back tomorrow for numbers, I believe it's 3 and 4.